40 horsepower Mercury computer scan test. Customer saying, and we witnessed it, an alarm after running a few minutes under load at full throttle would get 3 beeps,
and then you go back, and then you give it full throttle again, be 6 beeps,
and then 6 beeps, and
never lost power though.
Never lost power, but that identified in the manual and such as map sensor and throttle position switch. Customer changed them both. We ran it one time and it did have an alarm. Now we're running it again. We had some problems with our scanner. It got broken, so we got our little scanner fixed. You can see the brand new shield on it. So right now we're going to just video and confirm all this engine's activity. So start it up and let's run through this scanner. Okay, we've already warmed it up. As you can see, the tattletale is telltale, whatever you want to call it. The peer is peeing good.
Yeah,
right, engine seems to be idling like it should. I mean, there's a little vibration, but these shake a little bit. Forward gear at idle. RPMs come up like they should. Let's get this scanner lost communication, so we're going to reset the scanner. Okay, and we're going to start at the top of the list here. We can see our engine idle speed, so forth, so on. We're going to just run through this. Idle set RPM is set at 755. Base RPM is 775. IAC position is at 0. Idle air control. Idle circuit mode, base idle, no offset. Engine is in running state. Battery voltage is 13.7. Ignition switch voltage 14.1. Sensor powered, all the sensors should be 5 volts, and it's at 5 volts. Barometric pressure, and it's our onboard weather station, is 30.4. Manifold pressure 12.5. Those all look good. Map sensor at 354. Map is in default, no. Mass airflow sensor at 175, volume of air. Available power 100%. Active fault power limit is set at 100%. So at 100%, you know, it should fault out so long as you're asking it for 100% power. Percent of maximum power right now at idle, we're using 3.4% of its power just idling. Load percent, don't ask me, 27%. Guardian cause, none. That would be a, a state. That would be a fault. Guardian state is off. Warning horn is not activated. We have a percent of demand just above idle is just barely 0.1. Throttle position switch is the same. Throttle position counts. That's how many times it's cycling to count where it's at. Air percentage, that's air going through the motor. Spark advance, the timing is reducing itself a little bit, which is fine. Coolant temperature looks good at 134. Air intake temperature is 104 degrees, which is not excessive. The IAT, I forget what that is, but I don't know. I forget. It slips my brain for a minute. The sun just came out, it's cooking my head. Emergency stop is not active. Emergency stop counts, it's cycling, looking for problems. Fuel pump is at 5.5 amps, roughly. Fuel per cylinder is about 17%. Fuel injector cycling is all equal for all the injectors. That's good, so we don't have an injection problem. Injection on time looks all good. Fuel flow rate, very little fuel flow. Oil pressure switch is normal. Starboard engine location, that's the end of the list. Okay, so we're going to get back up to the top of this list. It's quite a few items. Okay, and now we're at engine speed again. So now Kenneth's going to go ahead and just ease on into the throttle until we're at full throttle. Now keep in mind this is full throttle in the tank. So the propeller keeps it from going, 4,500 RPMs or so, but we're going to ask it for 100% of its power. So it's going to have to try to deliver that. That's like pulling the boat with your truck, it's under a heavy load. engine speed, 3,300. IAC position, 100%. Battery voltage, looks good. Ignition switch voltage. So battery volts came up, shows our charging circuit is working. Sensor power still looks good. If we saw a reduction in that, we could say we had a problem with the ECM. Barometric pressure is on target. Manifold pressure is damn close to barometric. That's what you want. Manifold AOC, ADC, I don't know, that's its counts or whatever. The map is not in default. Mass airflow sensor, that's the air flowing in. Available power 100%. Active fault power limit still at 100%. Percent of maximum power being used is 58%. Load percent is 85% load. Guardian cars, no codes. Guardian stayed off. Warning horn off. We're asking it for 100%, so we're demanding 100%. Throttle position is at 100%. And so forth and so on. GPS air per cylinder, 256. Responding. Ignition advanced, 20 degrees. Coolant temperature under load, 148. Air intake temperature, come up a couple of degrees. Emergency stop, so forth, so on. Fuel counts. Fuel pump voltage still looks good. I mean amps, I'm sorry. If those amps are kind of high, then we could suspect the fuel pump was having a problem. Fuel per cylinder, we're at 65%. Injectors look good. Injectors are on time, or the time of the injectors. Flow rate, 2.2 gallons per hour at 3,400 RPMs. Oil pressure switch normal, and that's that. And we have no alarm. So whatever was ailing this engine maybe has corrected itself. Mercury ECMs will do that sometimes. Sometimes you just have to run them for a while until they reset. At this point, we have no reason to think anything's wrong with the engine. So we have to give it a clean bill of health. It's going to have to go out on the lake for a lake test. And the customer will respond back. If it does get an alarm out on the lake at higher RPMs, then we're going to know it's an RPM related issue. The beeps don't make sense. We also did a battery test looking for a shorted cell. Some of these batteries on these Mercuries are very finicky. The Mercury does not like to have a shorted cell in a battery. The battery's a little low, or the battery is having problems, or a weak or bad connection. It can cause the engine to do all kind of weird stuff. So the battery looks good on it, and again, we have no reason to think that there's any faults. Now, just to talk about a little bit about load testing in a tank. And we've got this running wide open the whole time we're talking here. You know, Yamaha and every other manufacturer that I know of doesn't put their motors on a boat and go ride them around on a lake. They do exactly what we're doing here. They put them in a test load tank with them hooked up to sensors while a technician looks over them with a flashlight to make sure everything's doing like it's supposed to. Once it passes those tests, it's set out to whatever, it's shrink wrapped, it's set off to whatever dealership ordered it or whatever customer. So this test in the load tank proves very, very effective. Very, very seldom do we ever have to take a boat out on the lake. To put that into a little bit better terminology, just imagine your truck having a problem and it's being tested under a full load to look for overheat or fuel problems. That's where those problems will show up, typically. But occasionally you'll get a high RPM problem that could be typically clogged fuel injectors or a fuel system issue, a quality of fuel issue, you know, something like that, an overheat issue, a blocked cooling system, especially on these motors. These are very good engines and they have very few problems like that. And that's all I have to say about it. I'm sure I've missed a few things, and I'm sure I'll get a little feedback from some people out there, but all in all, this is kind of a quick 10-15 minute test of this engine looking for problems, and in my opinion, it's passed. Hope this helps some of you understand what your computers are doing and what the settings would be and how your engine would be performing at full throttle under a load. Thanks for watching.